Good afternoon. Welcome to Chemistry of the Peter, Take 3. I am asking you to pause the video and write this out. Balancing redox equations in acidic solution. Pause, write it out. Okay? I'm assuming you've written out the problem, you've restarted the video. I want you to get your periodic table set, the handouts, and last page, bottom half, balancing reduction oxidation equations. There's some steps you're going to follow along. Get that up. Okay? I'm assuming you've got it. Now, the first step is separate the two half reactions, balance what you can without worrying about oxygen or hydrogen. Well, I noticed here that this is probably one of the half reactions. Then this will be the other. So let's write them. M-N-O-4 N-N-N-R. The other one, H2O2, hydrogen peroxide to oxygen. Step 1 says separate the half. Done that. Balance what you can without worrying about oxygen or hydrogen. Okay, first, Mn, there's one group of Mn. Good. Second one is exclusively hydrogen and oxygen. We're not worried about that this time. Step 2, balance for oxygen using water if necessary. Water has one oxygen per mole. So I look at this. The reactant side of this half reaction has 4 waters, so we need 4 waters on the products. Now, oxygens are balanced. Second half reaction, 2 and 2. We don't need to add any waters, it's already balanced for oxygen. Third step, balance for hydrogen using the hydrogen H plus if necessary. First half reaction, product side we have 4 times 2, 8 hydrogen on the right hand side on the product side. That means we need 8 on the left side, the reactants. I'm going to put the groups of hydrogen ion. This is an acidic solution. Hydrogen ion is what's given up right after. That's why we use H plus. That one's done. Second one, 2 hydrogens. No hydrogens on the products, so we need to add 2 hydrogens. We are done with step 3. Step 4, balance for charge by adding electrons. Okay. First half, we have 8 positives, 1 negative, so that's 7 on the reactants. We have 2 on the product side. Let's bring the high side down to the low side. 7 needs to come down to 2. That means 7 minus 5. 5 negative electrons are added. So 5 electrons. Second reaction. No charge. There's nothing indicated there, so no charge on the reactant side. There is 2 groups of positive 1 on the product side. That means we got to bring 2, the high side down to the low side, 0. 2 down to 0, that means add 2 electrons. In. 2 electrons. Okay, good. Ready to add these equations up almost. Just so it doesn't get as messy, but we can still refer to this. And copy, paste, and paste. So I've just rewritten this. Okay. Now, divide this up. Step 5 says add the 2 half reactions, canceling it out, combining repeated species. Repeated. No, you should not have any electrons left after you add them up. You may have to multiply half reactions to match electrons from the reduction oxidation half reaction. By the way, oil rig. Oxidation is losing electrons. Reduction is gaining electrons. This wasn't asked directly, but I just picked up the size. Reduction is gaining electrons. This is reduction. You're adding in the electrons. You're losing the electrons in this half reaction, so this is oxidation. I can't make X over that. Or an O. That's an oxidation. Getting back to this problem. Add the two half reactions, canceling out repeating things. But we need matching electrons. That's 5 electrons, 2 electrons. Lowest common multiple, that's got to multiply by each other. 5 and 2, 10. You need 10 electrons on both equations. This is why I thought. If I multiply the first reaction by 2, I will get 5 times 2. 5. 8 times 2. 16. 1 times 2. 1 times 2. 4 times 2. All right, from the 1. 4 times 2. 8. Second reaction, we multiply everything by 5. 5. 5 times 2 is 10. So that. And 2 times 5 is 10 for the electrons. We have matching electrons with 2. Now we can add the half reaction. Anything repeated? Well, for sure, the electron. And water's not repeated, but hydrogen is. There's 16 hydrogen on the reactants. 10 hydrogen on the products. There's more on the reactant side. We're going to cancel out the 10 on the product side. There's more on the reactant side, so we're going to say 16 minus 10. That will cancel out. There's 6 hydrogen on the reactant. Let's add this puppy up. 6H plus. 2M. 5H2 plus. That's all I'm left. On the right hand side. 2 manganese. 8 waters. 5 oxygen. We are done. So there's another example that what I want you guys to do is to do some practice on these acidic reactions. Just bring that up in a second. You guys have a handout, or you should have a handout. Looks like this. And I want you to do these questions here that the acidity. And it says in number 3 here. Balance the following redox reactions, assuming acidic conditions, unless basic is specified. So I want you to do A, C, D, E. You will do the basic ones, but I'll have to show you that out. Good luck.